Unit 9 is on graphing standard form. So we've already talked about graphing factored form, and now we are going to look at graphing the standard form, which is y equals ax squared plus bx plus c. So hopefully you recognize that form from when we were factoring. A lot of stuff is going to stay the same. So we already know that if a is positive, our parabola will open up. We know that if a is negative, our parabola will open down. We know that as a gets larger, our parabola gets narrower. And we know that as a gets smaller, our parabola gets wider. All of that is going to stay the same. Here's what's new. So looking at our standard form, we have a new way to find our axis of symmetry and our vertex. So in order to find the axis of symmetry, we're going to use this formula, x equals negative b divided by 2a. And notice that our b and our a come right from our standard form. They come right from our standard form. We just plug them in and then work out that math. So that means, here's my axis of symmetry, x equals negative b divided by 2a, which would mean that my vertex would have an x value of negative b divided by 2a, and then whatever that number was, I would just plug it in to find my y value. The other thing that changes is our y-intercept. So our y-intercept is always going to be the c value. So if we think about this, the y-intercept is where x equals 0. So if we plug that into our general form here, or our standard form, a times 0 squared is just 0, b times 0 is just 0, plus c. 0 plus 0 plus c tells us that y is equal to c. So that's why our y-intercept will always be the c value. Now, yesterday we practiced identifying our a, b, and c. And so today, before we start graphing, we're going to talk about something called the parent function. So the parent function is the simplest quadratic equation. Every other quadratic equation is just a variation. It stems from this parent function y equals x squared. So y equals x squared, in order to figure out what that graph looks like, basically you just square the x to get y. So for example, if x was 0, that would mean y equals 0 squared. Well, 0 times 0 is just 0. If x equals 1, well, 1 squared is 1 times 1, so that's just 1 over 1 up 1. If x is 2, 2 squared is 2 times 2, which is 4. And then we have 3 squared, 3 times 3 is 9. Notice how we have that right-hand side of our parabola, and for our parent function, our axis of symmetry is the y-axis where x equals 0. So we could just mirror it, but just so you can see, if we picked a negative x value, well, negative 1 squared would be negative 1 times negative 1. Well, negative times a negative would leave us with a positive 1. So notice how we go negative 1, up 1. So we're just mirroring those points across our y-axis. So this is our parent function. All right, so this is our parent function, and our parent function is has an a value of 1. And so we're going to use the properties of this parent function in order to take a shortcut when we are graphing. So what happens when a is not equal to 1? Well, if we keep these same x and y values, 0, 1, 1, 2, 4, and 3, 9, we can use this shortcut to graph. And so what happens when a is not equal to 1? Basically what we do is we keep those same x and y values, but we take our a value. So for y equals negative 2 times x squared, a would equal negative 2. And then to figure out how this changes the graph, we take our a value and we multiply it by this y column. So for the first one, I take negative 2 and multiply it by 0. Well, that's just 0. For the next one, I take negative 2 and multiply it by 1. Well, that's negative 2. Then negative 2 times 4 is negative 8. Negative 2 times 9 is negative 18. So when we were graphing, we would be done with this middle column. We wouldn't care about it anymore. And we would use our x and our AY column to graph. So let's practice just finding this AY column a couple more times before we look at how this helps us with our graph. So for the second one, our a value is 4. Well, 0 times 4 is 0. 1 times 4 is 4. 4 times 4 is 16, and 4 times our y value of 9 is 36. So these change, so again, we don't care about this middle y column anymore, so we would use our x and our AY column to graph. For this last one, go ahead and pause the video and see if you can figure it out. When a is negative 3, AY would be 0, negative 3, negative 12, negative 27. And again, our x tells us how far over to go, and our ay tells us how far up or down to go from our vertex. And that's how we're going to use this to graph. So let's put this into practice. If we wanted to graph something like y equals x squared minus 2x minus 3, we just need to fill out this information over here. Well, looking at this, it's got an a value of 1, so it's going to open up. Our axis of symmetry, remember we're going to use this equation, x equals negative b divided by 2a. Well, for this problem, b is equal to negative 2, so we would have a negative times negative 2 divided by 2 times 1. Well, negative 2 is just 2, 2 times 1 is just 2, 2 divided by 2 leaves us with an axis of symmetry of 1. And if we know that, we know the x value of our vertex. So this part's the same. Once we have our x value, we just plug it in to find our y value. 1 squared is 1. Negative 2 times 1 is negative 2. 1 minus 2 minus 3 is negative 4. So we have our vertex of 1, negative 4. So 1, negative 4, I'm going to graph that. That is the center of our parabola. That is the center, or the main part that we are going to use to graph the rest of this parabola. So if you think back to last unit, at this point we'd have to find our other points on our parabola so we could graph it. And to do that, we would pick x values and plug them in to find the corresponding y values. But we are going to use our shortcut. So we're going to use our x, y, ay table to make graphing this a little bit faster. So my x and my y column are always going to be the same. 0, 1, 2, 3, 0, 1, 4, 9. We're always going to keep those same numbers. The part that will change is this ay column. So for this particular problem, we said that the a value is equal to 1. Well, 1 times 0 is 0, 1, 4, and 9. So notice that for that particular one, our a didn't actually change. But we're going to use this by starting at the vertex. So start at the vertex. Our vertex would be right here, 0, 0. So we're not going to move from the vertex. And then we're going to go over the x amount, and we're going to go up or down the ay amount. Notice how the ay values are positive, so we're going to go up. So I'm going to start at this vertex, and then I'm going to go over 1, up 1, over 1, up 1. Then I'm going to go back to my vertex, and I'm going to go over 2, up 4. So 1, 2, up, 1, 2, 3, 4. Then I'm going to go start at my vertex again, go over 1, 2, 3, and up 9. And then I can mirror those points on the other side of my axis of symmetry. And again, all this does is make our graphing process faster. So we're using that shortcut, those principles of that ay value, in order to graph this. Okay? And notice that these are the same points we'd get if we were to pick the x value. So right here we've got the point 4, 5. If we had picked the x value of 4 and plugged it into our equation, we still would have gotten 5. It's just using our x, y, ay table makes it a little bit faster. Okay. Oh, and we forgot one thing, the y-intercept. Remember, that's just our c value, so that would be the point 0, negative 3. Notice how that matches what we got when we used our x, y, ay table to graph. Let's practice this a couple more times. So if we had y equals negative half x minus 1 plus 1, well, this would open down because a is negative. Well, our axis of symmetry, this would be a good time to pause and see if you can plug our numbers in and do the math for yourself. You should end up with negative 1. And if x is negative 1, just plug that in to find y. Well, we'd end up with negative half plus 1, which is just 1.5. So we have this vertex of negative 1, 1.5. So right here, I'm going to graph my axis of symmetry because I'll need that. My y-intercept is just that c value, so I'll have the point 0, 1. That should end up on my graph. And again, this table, I'm going to have 0, 1, 2, 3, 0, 1, 4, 9. Now this time my a value is negative 1/2, so when I multiply that, I'll have 0, I'll have negative 1/2. 4 times negative 1/2 is negative 2. 9 times negative 1/2 is negative 9 over 2, which is the same as negative 4.5. Notice that my AY column changed, so I'm done with this middle column. I'm going to start at my vertex. I'm going to go over my X value, and since my AY, since these are negative, I'm going to go down. Okay, so starting at our vertex right here, we go over 1 and we go down half. And notice how that's our y-intercept. Then we do it on the other side, over 1, down half. Then starting back at our vertex, we're going to go over 2, 1, 2, and down 2, right here. And then, of course, we're going to mirror that point. And then again, starting at our vertex, we're going to go over 3, 1, 2, 3, down 4.5. So here's down half, down 1, 2, 3, 4. And that's how we graph it. And notice how fast that is. It's really slick. So we're going to do one more. It'd be a good idea to pause the video and see if you could figure this out for yourself. This one's going to open down. Our axis of symmetry with our negative b divided by 2a. Well, that'd be a negative 2 divided by 2 times negative 1, which is just 1. When we plug that in, we end up with y equals negative times 1 squared plus 2 times 1 plus 6. Well, 1 squared is just 1, so we have negative 1 plus 2 plus 6 would be 7. So we have our vertex of 1, 7. 1, 2, 3, 4, 5, 6. Oops, lost count. 1, 2, 3, 4, 5, 6, 7. And then here's my axis of symmetry. My y-intercept is going to be the point 0.06 because my c value is 6. Okay. So this xy column you can figure out immediately, right? You should always plug that in first. That's never going to change. Here our a value is a negative 1. So all of these are going to switch signs. So instead of going up that much, we're going to go down that much. So starting at our vertex, I'm going to go over 1 and down 1. Okay, on both sides. And starting at my vertex again, I'm going to go over 2 and down 1, 2, 3, 4. And then again on the other side, over 1, 2, down 1, 2, 3, 4. And then over 1, 2, 3, down 9. And again, I'm going to do that on the other side. And here's our parabola. So we're going to practice this tomorrow. Make sure that we're feeling really comfortable with this X, Y, AY table. If you have any questions on that X, Y, AY table, write it down or send me a Schoology message. So just to review, this is all of the new information when we're looking at our standard form.